Hello, I'm Siddhartha Shokamben, a third year Electronics and Telecommunication Engineering student at Tatasaheb Kore Institute of Engineering and Technology. Before I begin, I would like to thank Emertxe for giving this opportunity. During the internship, which was of 4 weeks, I was able to work on a project that is microwave oven, and our project guide is Jayalakshmi N. Danayal. The goal of the internship were to understand how embedded system and its concepts are. I was able to gain knowledge of embedded systems concepts. Also, I had experience dealing with microcontrollers. Also, I implemented a real-time application on PICSimlab. So, learn a lot like how implementation is done. So, the topics discussed during the internship were introduction to C, conditional statements, loops, array, functions, strings, storage class, etc. Also, we learn about what is embedded systems, microcontrollers, worked with MPLAB XID, PICSimlab, XE8 compiler, and introduction to various peripheral of PIC16F8778 microcontroller. Also, the interfacing various peripheral of PIC18F877. So, what are the contents we will be covering in this presentation? It follows as C programming, what is micro oven, what were the requirements of the internship, what is embedded system, difference between microcontroller and microprocessor, CLCD display, matrix keypad, ISR, and finally we will be completing with our project implementation. Okay, so we learn about C programming, in which uh, basics of C was taught. In data types, I was exposed to different data types like integers, float, characters, boolean, long, double, and in operators, which performs operations on variables like arithmetic operators, where and logical operators were discussed. And remember, they are essential for building expressions and making decisions in code. In decision making, like if else switch, which are used to execute a specific load upon condition. So we learn about loops, which is used to repeat a state, a condition given in a code, and the functions, which are usable blocks of codes that perform a specific task when called, and the pointers, which are variables that store memory address of other variable using the operators. At last, we learn about strings are the sequence of characters stored as array in C, which are enclosed in double quotations. Let's move on to the next slide, that is introduction to microwave oven. A microwave oven is an kitchen appliance that usually used to heat and cook food quickly, where we use microwave radiation for it. Usually, a microwave oven has several cooking modes, but the very basics four modes are the micro mode, the grill mode, the convection mode, and start mode. The microwave mode is a standard mode which is quick and efficient of cooking the food, where we heat the food. We use most of the time this mode to reheat the leftover food which we heat in a matter of seconds. In this, a uniformly heating is provided for the food so that there is brown and crispy exterior, and for that we don't need to apply much of the fats and oil. Second is the grill mode. The grill mode uses a heating element on the top of microwave to brown and crisp the top of the dishes. It is perfect for creating a golden crust on casseroles, melting cheese, and achieving a grilled texture on certain food. It is used for a wide range for dishes like cheesy lasagnas to sandwiches. It allows a more versatile cooking as it combines with microwave heating with grilling. Now third, that is the convection mode. The convection mode is for baking and roasting. It utilizes a fan and a heating element to circulate hot air, making it ideal for baking cookies, cakes, and roasting meats. It provides even cooking and browning similar to the traditional oven. The convection mode is known for its producing dishes with a crisp exterior and tender interior, enhancing the texture and flavor of the various recipes. Start mode. Start mode is a basic default setting in microwave, and it is used when we want to heat and cook something without using any much standard mode. Simply input the desired time and power level, then we can press start, then eventually we will get the result. It is a versatile option for various cooking tasks. So what were the project requirements? MPLAB XID is used for the programming. Also, we use XE8 compiler. It is a 8-bit PIC and AVR microcontroller familiar. And third is a PICSimlab, which is a software. It is an open source software through which we can simulate any circuit design through it, and it's working. We learn about PIC16F877A microcontroller. Second, where the 16 into 8 CLCD display, tactical switch were there, timers were there. So let's move on to the definition of embedded system. The definition of the embedded system goes as: they are specialized computer systems designed to perform dedicated functions or tasks within a large system. They are embedded into various devices and applications ranging from consumer electronics like smartphones, washing machines, to industry machines like CNC machines, automotive control systems. The purpose of embedded system is to control and monitor and manage the operation of these devices efficiently and autonomously. So let's move on to the characters of. It performs a real-time operation. Many embedded systems operate in real time, meaning they must respond to input and perform tasks within restricted time constraints. It has resource constraints, like we have a limited computing resources including memory, processing power and energy. Designers must optimize software and hardware to work within these constraints. Reliability. Reliability is paramount in the embedded system, especially in safety critical application. Failure can have serious consequences, so extensive testing and redundancy are common. Integration. The embedded system are tightly integrated with the hardware they control. They may include microcontrollers, microprocessors, sensors, and communication interfaces. And the most important is customization. These embedded systems are typically custom designed for specific applications or the devices, allowing us for the precise tailoring to meet the requirements of the task at a hand. The components of the embedded system are a power supply, a reset, and oscillator circuits are used. The processor, in a short form, that is MCU, which is the brain that executes the instructions controlling the system's operation. It has memory like RAM, used for temporary data storage and working memory, has ROM slash flash, which is non-volatile storage for firmware and control program. It has input output interfaces, which controls the sensor that is input and displays the output through actuators and displays like buttons like LEDs, LCDs, and analog to digital converters. It has communication interfaces like ports USB, I2C, SPI, Ethernet, Wi-Fi, Bluetooth for talking to other devices or networks. The supporting components are the software, the specialized code that defines a system's function from simple bare metal code to complex applications. Then is RTOS, which stands for Real Time Operating System, which simply manages the time, ensures timely responses, and supervises the software execution. It has timers and counters used for timing events, generating delays, and watchdog functions. Now let's move on to the next slide, that is microcontroller versus the microprocessor. Here we can see there is a differentiation between microcontroller and microprocessor. Microcontroller is a specific purpose CPU runs at lower frequency, whereas the microprocessor runs at high frequency. If we compare the speeds, microcontroller is slower as compared to microprocessor. The microcontroller supports RTOS, that is real time operating system, whereas microprocessor supports RTOS plus kernel based services. The complexity of hardware is relatively simple in microcontroller, and in microprocessor it is more complex. The prominent examples of microcontrollers are 8051, PIC, MSC430, STM microcontroller, and the examples of microprocessor are x86, Motorola, broadband, and Pentium. Now let's know more about PIC 16F877A, which has features like it is a 40 pin microcontroller which is operating at 20 megahertz with 8 KB flash memory and a 368 bytes of RAM. It has features like 5 input output ports with 32 GPIO pins, has 8 channels, 10-bit ADC for analog input and 3 timer counter modules, and PWM capabilities for motor control. It supports SPI I2C communications, has an on-chip USRT for serial communication, includes watchdog timers and power on reset circuitry, and it consumes very low power, making ideal for embedded system projects. And it can be programmed by using C language on MPLAB XC8 compiler. The components are used in this project are: the first is CLCD, which stands for character liquid crystal display. In PICSimlab there are two types of display: 16:2 display, 16:4 display. The display ASCII characters and some special characters. There are two types of communication module: 4-bit module and 8-bit module. Typically in this we work on 4-bit module. Next is matrix keypad, which has structure. The matrix keypad has a grid of buttons organized in a row and columns. At the digital output, when a key is pressed, it creates an electrical connection, providing an electrical current. So we get a digital output. It is a compact and a cost efficient, so that when input is provided we get the output when we press the button. It is used for various applications like calculators and remote controls. Here is the operation given in video. The tactical switch. It is a switch whose operation is to perpetuable by touch. This switch is used to select the mode of operation and to enter the temperature and time in a project. This switch produces bouncing effect when we press the switch. Interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller in which an internal external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends the request, goes back to the processing where it was got interrupted. Now let's move on to the ISR, that is interrupted service routine. An ISR is a software routine that hardware invokes in response to an input. ISR attends to request of an interrupting source by clearing the interrupt flags and should save register contents that may be affected by the code in ISR. It must be terminated within the instruction. RATIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupts, enables and places the address from program counter 1 to the clock. The timers, it is an important application in embedded system, which is a default peripheral which maintains the timing if an operation in sync with the system clock or an external clock. It has various applications like measuring time and generating delays. The conclusion: the project is successful, simulates the operation of microwave oven, and it provides the practical exposure to embedded systems, UI handling, and real-time control logic. Now let me show you the code. Here is the code that we have used. These are the source files. These are the header files. Now it's time to show you the project. Here the powering on and microwave shows on the display. I can restart it. You can see powering on, microwave oven is on, switched on. So here are the four modes which I discussed previously: micro, grill, convection, start. So let's begin. First we will select the micro. Here the power is displayed 900 volts. Here we have to set the timing. Okay, again I am doing this. Okay, so the timing will be of just 11 seconds. Let me just enter. Here the fan has started, the timing countdown is begin. Here I can start, resume, pause and stop. Here the countdown has begun. 16, 17. If I want to stop it, I can stop. I can pause this. Okay, so we have to start this timer. We have to press 4. Timer started. Okay, so cooking time is up. Second is the grill mode. Okay, so I will put off 30 seconds only, and I will press enter. So has the countdown has begun again. Can stop this by pressing the keypad. Okay, I have stopped. Third is the convection mode. I can set here the temperature to 40°C. Press enter. So here is the preheating option. Here it will display the time remaining. In seconds. Okay, I will stop this by pressing reset button. Here we will click on 4, start button. The timer has started of 30 seconds. So we got message that cooking time is up. So this is all about the project. Thank you.